Bismillahirrahmanirrahim. We'll continue with the midbrain and details about some other important internal features of the midbrain. We will discuss first the substantia nigra next to crus cerebri. Now a section through midbrain. In front is the crus cerebri, which we discussed in the last lecture in detail. And posterior to it is the substantia nigra. On both sides, separated by interpeduncular fossa. Central canal, the cerebral aqueduct traversing the midbrain, surrounded by central gray matter. Then tactile region, having nuclei of the superior and inferior caliculi. Now, substantia nigra, we divide into two parts, a dorsal part and a ventral part. This is dorsal part of the substantia nigra, which is known as the pars compacta. And this is ventral part of the substantia nigra, called pars reticularis. The dorsal part, the substantia nigra, it is located between the crus cerebri in front and tegmentum behind. We divide it into two parts, a dorsal part and a ventral part. The dorsal part of the substantia nigra is known as the pars compacta, while the ventral part of the substantia nigra, it is known as the pars reticularis. Now, in the pars compacta, the neurons are closely packed. While in the pars reticularis, the neurons are comparatively few and they are loosely disposed. They are widely dispersed. Now the neurons of pars compacta, because they are closely packed, so the dorsal part of the substantia nigra appear more denser, more dark as compared to the ventral part where the neurons are loosely located. Now basal ganglion, the substantia nigra, it is the only part of basal ganglion which is located outside. Substantia nigra is the only part of basal ganglion which is located outside the cerebrum. That it is located in the midbrain. Rest of the components of the basal ganglion, they are located in each cerebral hemisphere. The substantia nigra, it regulates the activities of basal ganglion. And is divisible into pars compacta behind and pars reticularis in front. Now, pars compacta of the basal ganglion pars compacta of the substantia nigra, not basal ganglion, the pars compacta of the substantia nigra comprising of closely packed dopaminergic neurons. These neurons contain, what are the contents of these neurons? These neurons contain dopamine, melanin, and iron. Melanin is the polymer of dopamine. These are the contents of neurons of pars compacta. So because they contain dopamine, therefore these are considered as dopaminergic neurons. This dopamine is synthesized in the neurons of neurons of pars compacta. Dopamine is synthesized in the neurons of pars compacta and are released into the corpus striatum. And are released into the corpus striatum of basal ganglion. Corpus striatum of basal ganglion, it comprises of caudate nucleus and putamen. The dopamine, which is synthesized in the neurons of pars compacta of the substantia nigra, they are released after synthesis into the corpus striatum of basal ganglion. Basal ganglion comprise of caudate nucleus, lentiform nucleus, and the lentiform nucleus further divided into putamen and globus pallidus. The caudate nucleus plus putamen of the basal ganglion is collectively known as the corpus striatum. Now, these dopamine synthesized by neurons of the pars compacta of substantia nigra are released into the corpus striatum of the basal ganglion through nigrostriatal fibers via nigrostriatal fibers. From substantia nigra to the corpus striatum, so nigrostriatal fibers. Suppose this is substantia nigra. This is pars compacta. Of substantia nigra. And this is pars reticularis. Pars compacta and pars reticularis of substantia nigra. Then basal ganglion. This is a lentiform nucleus. Outside is the putamen. Then globus pallidus. This is the putamen, and this is the globus pallidus. The outer one is called globus pallidus externus, and the inner one is called globus pallidus internus. globus pallidus. Now here is the caudate nucleus. Caudate nucleus. Sorry. Now the putamen and caudate nucleus is collectively known as the corpus striatum of basal ganglia. This putamen and caudate nucleus. These two collectively is known as corpus striatum. Of basal ganglia. Now the dopaminergic neurons of pars compacta of the substantia nigra synthesize dopamine, and this dopamine is then released into the corpus striatum of the basal ganglia. That is, it is released into the putamen and caudate nucleus via a pathway known as the Nigrostriatal pathway. From here, the dopamine is released into the corpus striatum of the basal ganglia. This pathway are nerve fibers. These are known as nigrostriatal fibers. Nigrostriatal fibers are dopaminergic fibers. So it is through the the nigrostriatal dopaminergic fibers that the dopamine in the corpus in the pars compacta of the substantia nigra is released into the caudate nucleus and putamen. And caudate nucleus and putamen are those parts of the basal ganglia which are known as the which is known as the corpus striatum. These were the connections and function of the pars compacta. In this way, the dopamine is released from pars compacta and stored into the corpus striatum. If there is damage to the pars compacta or to the nigrostriatal or dopaminergic pathway, there will be deficiency of the dopamine in the corpus striatum. It will result in a condition known as the parkinsonism. And this condition already we discussed in detail. I will just summarize. The parkinsonism, it is featured by some very prominent features, that is number one, there is rigidity. Then there are loss of associated automatic movements. Rigidity, the body becomes rigid, stiff. Then there are some automatic associated movements. That is when a person walks, he swings his upper limbs. When a person yawns, he stretches his limbs. These are automatic associated movements. So in it there is associated automatic movements are lost in parkinsonism. Then there are tremors which are present even in rest. A patient suffering from Parkinsonism, even if he is sitting or lying down and not performing any motor activity, tremors will be present. So tremors are present even at rest. And there is hypokinesia. Hypokinesia means difficulty in initiating a movement. Difficulty in initiating movements, hypokinesia. So these are some of the important features of Parkinsonism. There are other features also which we have already discussed in detail in the previous lectures. I just repeated some of the very important features. Now there is a mnemonic regarding some of the features of Parkinsonism, that is rate, heart, R stands for rigidity, A for associated movements, T for tremors, and heart for hypokinesia. So this mnemonic will help to remember major important features in case of Parkinsonism. That is rigidity, loss of associated automatic movements, and tremors even present at rest, and hypokinesia, difficulty in initiating movement. Now this was about the pars compacta. Now what about pars reticularis? Pars reticularis of Substantia nigra. The neurons are loosely and widely spread in this region. Pars reticularis It is continuous with globus pallidus. Internus of basal ganglion. It is continuous with the globus pallidus internus. As I drawn in this diagram, this is lentiform nucleus. Outer part, lentiform nucleus, the outer part is called putamen and inner part is called globus pallidus. The globus pallidus is further divided into globus pallidus externus and the inner one is known as the globus pallidus internus. So this part of the substantia nigra, that is the pars reticularis, it continues above with the globus pallidus internus, and pars reticularis of substantia nigra resemble with the structure of globus pallidus internus. So it is not only continuous with it, but also pars reticularis is structurally resembling the globus pallidus internus. Now, what are the neurotransmitters in substantia nigra? Neurotransmitters. In substantia nigra, in pars compacta and in pars reticularis. In pars compacta, the neurotransmitter is substance P. That is SP, substance P. Now, what are the neurotransmitters in the pars reticularis of substantia nigra? These are GABA, gamma amino butyric acid, GABA, 5-HT, 5-hydroxytryptamine, 5-HT, eukephalan, eukephalan. And also substance P. These are some of the neurotransmitters located in the pars compacta and pars reticularis of the substantia nigra. Now, what are the functions? Just briefly, the substantia nigra is concerned with the motor system of the body. concerned with motor system of the body, and it is considered as part of extrapyramidal system. Considered as part of extrapyramidal system. This was regarding role of substantia nigra or function of substantia nigra. Now, connections of substantia nigra. Connections of substantia nigra. As we know, substantia nigra comprise of pars compacta and pars reticularis. So, connections of pars compacta and pars reticularis of substantia nigra. Now, as I explained in this diagram, the pars compacta is connected with the corpus striatum, that is caudate nucleus and putamen, via Nigrostriatal or dopaminergic pathway. Connected to the corpus striatum of basal ganglion. Through Nigrostriatal or dopaminergic pathway. These dopaminergic or nigrostriatal fibers, they originate from the pars compacta of the substantia nigra, and they become in connection with the caudate nucleus and putamen of the corpus striatum of the basal ganglion. This was the connection of pars compacta of substantia nigra with the corpus striatum. Then connection of the pars reticularis the pars reticularis. It is connected with the parts of the corpus striatum. The fibers, they originate from the basal ganglion, that is from the corpus striatum, mainly the caudate nucleus, putamen and caudate nucleus. Fibers originate from the corpus striatum of basal ganglion, mainly the caudate nucleus, and of course also putamen. And these fibers they terminate in the pars reticularis of the substantia nigra. These fibers are known as the striatonigral pathway. So pars reticularis of substantia nigra is connected to the corpus striatum, particularly caudate nucleus. Via another pathway which is known as the striatonigral pathway. Striatonigral pathway. So you can see this is striatonigral pathway. In case of pars compacta, the nerve fibers, dopaminergic nerve fibers of the dopaminergic neurons of the pars compacta, they arise and terminate in the caudate nucleus and putamen, that is in the corpus striatum. And they release dopamine from pars compacta of substantia nigra to the corpus striatum. Then what about connection of the pars reticularis? The pars reticularis is connected again with corpus striatum, especially caudate nucleus, via fibers known as the striatonigral fibers. Now these fibers originate from corpus striatum. Nigrostriatal fibers originate in the pars compacta and terminate in the corpus striatum, while the striatonigral fibers for pars reticularis, they originate in the corpus striatum, especially the caudate nucleus of the basal ganglion, and terminate in the pars reticularis part of the substantia nigra. So these were connections of the substantia nigra. So with this we finished with the detailed features of the substantia nigra located in the midbrain. So we finished with the detailed features of crus cerebri in the last lecture. Then we discussed the detailed structure of substantia nigra in 2 days lecture. Next is the central gray matter surrounding the aqueduct. Now we know if we cut a longitudinal section through the midbrain, this is the cerebral aqueduct which traverses through the midbrain. superior calculi, inferior calculi, pons, medulla oblongata. Now this cerebral aqueduct it's surrounded by a layer of gray matter known as the periaqueductal gray matter or central gray matter. This is cerebellum. So in this way you can see the cerebral aqueduct connect the third ventricle, which is located here, with the fourth ventricle. And this cerebral aqueduct is surrounded by a layer of gray matter known as the central gray matter. Periaqueductal or central gray matter. Above the central gray matter surrounding the cerebral aqueduct is continuous with the gray matter of the third ventricle covered by ependyma, and below the central gray matter is continuous with the gray matter of the floor of the fourth ventricle. This is floor of the fourth ventricle, and of course covered by the ependyma. This is the pose ependyma. This is floor of the fourth ventricle, and the cerebellum, anterocerebral notch is forming the roof of the fourth ventricle. And third ventricle is here. Now this central gray matter comprise of neurons with a network of fibers. Now, I will draw another diagram. Suppose this is like the section through cerebral aqueduct. Longitudinal section through cerebral aqueduct with lumen inside. Cerebral aqueduct. I told you it is surrounded by gray matter. Central gray matter or periaqueductal gray matter. longitudinal section through the central gray matter surrounding the aqueduct of sylvius or cerebral aqueduct. This central gray matter, as I told you, comprise of neurons. Gray matter comprise of neurons and network of nerve fibers. Now, apart from a network of nerve fibers and neurons in the central gray matter, there are cranial nerve nuclei also in the gray matter. Which cranial nerve? Oculomotor nerve. Oculomotor nerve nucleus. And trochlear nerve nucleus. The motor nuclei of these two cranial nerves are also located. Suppose longitudinal section here in the central gray matter anterolateral to the cerebral aqueduct at the level of superior calculus. This is a oculomotor nerve nucleus. And at the level of inferior calculus anterolateral to the cerebral aqueduct is the trochlear nerve nucleus embedded in the central gray matter. Oculomotor nerve nucleus. Trochlear nerve nucleus. And also there is a mesencephalic nucleus and tract of the trigeminal nerve. Mesencephalic nucleus and sensory tract of trigeminal nerve. The oculomotor nerve nucleus is only located in the upper part of its course, that is at the level of superior calculus, in the central gray matter, anterolateral to the cerebral aqueduct, while the trochlear nucleus is present in the lower part of the midbrain, in the central gray matter, anterolateral to the cerebral aqueduct at the level of inferior calculus. But the mesencephalic nucleus and tract of trigeminal nerve is located in the central gray matter throughout its extent, both upper and lower parts of the midbrain. This is mesencephalic nucleus of trigeminal nerve. Suppose here is a oculomotor nerve nucleus in the central gray matter, anterolateral to the cerebral aqueduct. the lower part, this is trochlear nerve nucleus. In the central grammator, anterolateral to the cerebral aqueduct. Oculomotor nerve nucleus. And this is trochlear nerve nucleus. And throughout its extent, right from its upper end to the lower end of the midbrain, in the central grammator, lateral to the cerebral aqueduct, this is the mesencephalic nucleus and tract of trigeminal nerve. Now in the upper part of the central grammator, dorsolateral to the oculomotor nerve nucleus, there is another nucleus known as interstitial nucleus of Cajal. Interstitial nucleus of Cajal on both sides. This is cerebral aqueduct. Now, on each side, lateral to the cerebral aqueduct, there is a bundle of nerve fibers. On each side. This is known as medial longitudinal bundle or medial longitudinal fasciculus. So I'll again repeat, this is a longitudinal section through the cerebral aqueduct. And this cerebral aqueduct throughout the extent of midbrain is surrounded by a layer of gray matter known as the central gray matter or periaqueductal gray matter. And this gray matter is composed of neurons and a network of nerve fibers. Apart from these, the central gray matter is occupied by the oculomotor nerve nucleus in the upper half of the midbrain, and below that is trochlear nerve nucleus in the lower half of the midbrain. And throughout the whole extent of the midbrain, in lateral to the cerebral aqueduct is the mesencephalic nucleus and tract of the trigeminal nerve. Now, in the central gray matter, upper end of the central gray matter, close to the upper end of the cerebral aqueduct, dorsolateral to the oculomotor nerve nucleus. On each side, there is interstitial nucleus of Cajal. Now, in the lower part of the posterior wall of the third ventricle, there is posterior commissure. This is suppose posterior commissure. Just I will repeat what is posterior commissure. You know the corpus callosum. Connecting the two cerebral hemispheres. Fornix, septum pellucidum. Anterior commissure, bundle of transversely running fibers, lamina terminalis, optic chiasma, then epipinal spinal body, posterior wall of the third ventricle. And in the lowest part is posterior commissure. Again, a transversely running bundle of fibers. Posterior commissure. And then you know the tuberous cinerarium, pituitary gland, right and left mammillary bodies, then the midbrain traversed by cerebral aqueduct. Pons, medulla oblongata, lower part of medulla oblongata, traversed by central canal, and this is cerebellum. You know the third ventricle, and this is the fourth ventricle. And I told you this is central gray matter surrounding the cerebral aqueduct and continuous with the gray matter lining the third ventricle, and below it is continuous with the gray matter lining the floor of the fourth ventricle covered by ependymon. So this is the posterior commissure, and this was anterior commissure. So we are here talking about the posterior commissure, bundle of nerve fibers. Now these bundle of fibers interconnect the interstitial nuclei of Cajal of two sides. These posterior commissure, they interconnect the interconnect what? Nuclei of superior caliculi. And interconnect the interstitial nuclei of Cajal. So this fiber bundle known as the posterior commissure comprise of fibers which not only interconnect the interstitial nuclei of Cajal with one another of both sides, and also interconnect the nuclei of superior caliculi. nuclei of superior caliculi. And already we talked about anterior commissure which connect the right and left rhinoencephalon. So this was somewhat detail about the central gray matter and cerebral aqueduct of the midbrain. Next, oculomotor nerve nucleus. This was substantia nigra. This was crus cerebri, which we discussed already, number 1. Number 2, our second topic was detail about substantia nigra, its structure. Then number 3, we talk about central gray matter. And now we are going to talk about oculomotor nerve nucleus. Now, oculomotor nerve nucleus, you can see here, it is located in the central gray matter, anterolateral to the cerebral aqueduct at the level of superior caliculi, that is in the upper half of the midbrain. And this diagram also shows longitudinal section, front view, you can see the oculomotor nerve nuclei located in the central gray matter, anterolateral to the cerebral aqueduct. Now, this was about location in central gray matter, anterolateral to cerebral aqueduct at the level of superior colliculus. It give rise to which fibers? The oculomotor nerve nucleus give rise to motor nerve fibers. Of oculomotor nerve. Now, a little detail about the oculomotor nerve nucleus. One right, one left. Now it is divisible into a number of smaller nuclei composed of or it is divisible into a number of smaller components composed of smaller components. Now these components in the lower part, right and left oculomotor nerve, in the lower part they join together to form oculomotor nerve complex. Right and left oculomotor nerve nuclei join together in the lower part. Forming the oculomotor nerve nuclear complex. Then rostral to the posterior part, rostral to the posterior part of oculomotor nuclear complex is the Edinger-Westphal nucleus. Edinger-Westphal nucleus. Now I will explain it with the help of a diagram. Now suppose this is right oculomotor nerve nucleus. And this is left oculomotor nerve nucleus. Comprising of small components. This is right oculomotor nerve nucleus. This is left oculomotor nerve nucleus. Now, when we trace the upper parts of the oculomotor nerve nucleus downward, what happens? The right and left oculomotor nerve nuclei, they join together. Same nuclei, they join together. To form oculomotor nuclear complex. Right and left oculomotor nerve nuclei join together to form oculomotor nerve nuclear complex. In the lower part of the lower part of upper half of the midbrain. Now, posterior to the rostral part of the oculomotor nerve nucleus, is the parasympathetic part of the nucleus of the oculomotor nerve. This is known as the Edinger-Westphal nucleus. Edinger-Westphal nucleus of oculomotor nerve. It is located posterior to the rostral lower two-thirds of the nuclear complex, behind the nuclear complex. This Edinger-Westphal nucleus is the parasympathetic, giving origin to the parasympathetic fibers. Oculomotor nerve is a motor nerve and one of the parasympathetic cranial nerve. So all these nuclei give origin to the motor fibers, and the Edinger-Westphal nucleus give origin to the parasympathetic fibers of the oculomotor nerve. So this was a little detail about the oculomotor nerve nucleus located in the centrogrammatar in the upper half of the midbrain at the level of superior complex. Now, the oculomotor nerve nucleus supply what? We discussed the location, we discussed the different components. Now, innervation. It innervate what? We discuss the location, then we discuss the divisions of the oculomotor nucleus, and the motor and parasympathetic fibers originating from the oculomotor nucleus innervate what? The parasympathetic Edinger-Westphal fibers of oculomotor nerve supply, number one, supply the constrictor pupillae muscle of the eyeball, supply constrictor pupillae muscle of the eyeball. Number one, these parasympathetic fibers are the oculomotor nerve which originate from the Edinger-Westphal nucleus of the oculomotor nerve. They supply the constrictor pupillae muscle of the eyeball. And number two, supply the ciliaris muscle of eyeball, muscle of the ciliary body. Then rest of the motor fibers of oculomotor nerve. Supply all the extraocular muscles of the eyeball. Except superior oblique muscle. And lateral rectus muscle of the eyeball. The parasympathetic fibers which originate from the agender basal nucleus subclavicular supply the unstripped muscle, that is the constrictor pupillae muscle of iris of the eyeball, and second ciliaris muscle of ciliary body. Of the eyeball. Now, rest of the motor fibers originating from oculomotor nuclei supply all the extraocular muscles of the eyeball, except two muscles, superior oblique and lateral rectus. Lateral rectus is also known as the rectus externus. The superior oblique is innervated by trochlear nerve. Another cranial nerve, superior oblique, is innervated by trochlear nerve, not by abducens nerve. And the lateral rectus muscle, or rectus externus, it is innervated by abducens nerve. Not by oculomotor nerve. So all the extraocular muscles of the eyeball are innervated by oculomotor nerve except two muscles. Superior oblique is innervated by trochlear nerve, and the rectus externus or lateral rectus muscle of the eyeball is innervated by abducens nerve. Now again there is a mnemonic to remember the innervation of the extraocular muscle of the eyeball. It will help you to remember the nerve supply. And what is the mnemonic? Regarding innervation of extraocular muscles of the eyeball. Now what is that? All the extraocular muscles are supplied by oculomotor nerve. Except sore. except sore. Remember the word sore, just like sore throat. Except sore. S stand for superior oblique. Superior oblique muscle of the eyeball. S-O. It's like this. Superior oblique muscle. Superior oblique muscle. And RE, rectus externus. Rectus externus or lateral rectus muscle, because it is located externally, laterally, rectus externus. Now, what is the nerve supply of these two muscles? The superior oblique is supplied by, as I told you before, superior oblique is supplied by trochlear nerve. While the rectus externus supplied by abducens nerve. So this is in mnemonic, which will help you to remember the innervation of extraocular muscles of the eyeball. So all the extraocular muscles of the eyeball are supplied by oculomotor nerve, except sore, superior oblique, rectus externus. Superior oblique is innervated by trochlear nerve. Rectus externus or lateral rectus muscle is supplied by abducens nerve. So this was mnemonic about this. Now I told you that lateral to this central gray matter is the medial longitudinal bundle. Or fasciculus. Now through the fibers of the medial longitudinal bundle, the oculomotor nerve is connected with the nuclei of fourth cranial nerve, sixth cranial nerve, and vestibulocochlear nerve. The nuclei of fourth cranial nerve, nuclei of sixth cranial nerve, and nuclei of eighth cranial nerve. You know, eighth cranial nerve is vestibulocochlear nerve. Fourth cranial nerve is trochlear nerve. Sixth cranial nerve is abducens nerve. And this is oculomotor nerve. Oculomotor nerve nucleus. So the additional knowledge which you should know, that you know lateral to the central canal are right and left medial longitudinal bundle or medial longitudinal fasciculus, which comprise of nerve fiber and also nuclei of different cranial nerves. So what is the relation of oculomotor nerve with the nuclei in the medial longitudinal bundle? It is important to know that the oculomotor nerve through medial longitudinal bundle is connected with the trochlear nerve nucleus, the abducens nerve nucleus, and the vestibulocochlear nerve nucleus. So today we discuss in detail some of the important internal structure of the midbrain. We talk about the substantia nigra. Then we discuss the central gray matter or periaqueductal gray matter detail. Then we talk about the oculomotor nerve nucleus. Thank you very much, and keep learning.